Hello students, under pharmaceutical chemistry 2, we were discussing drugs acting on nervous system. We have already finished up with the first set of drugs which are classified under drugs acting on nervous system, that is drugs acting on CNS or central nervous system, which includes CNS depressants and CNS stimulants. Then we began our discussion with drugs acting on autonomic nervous system. We had an introductory discussion about autonomic nervous system. That means this system enjoys some sort of autonomy or liberty with regard to its functioning. Then this system governs the activity of many organs or systems through its through its two parts, that is one sympathetic nervous system or adrenergic nervous system and parasympathetic nervous system, or which is also known as cholinergic nervous system. We had our discussion on sympathetic drugs or adrenergic drugs, which includes sympathomimetics and sympatholytics. Now we began our discussion with parasympathetic drugs or cholinergic drugs. This term parasympathetic drugs or cholinergic drugs is a general term which is used for all the drugs which acts on various components of parasympathetic nervous system like nerves, synapses or effector organs, ganglion, etc. Now, as under sympathetic nervous system, we have seen that there are two types of drugs or agents which acts on sympathetic nervous system. One we call them as sympathomimetics and another sympatholytics. On the same lines, here also we have two types of agents which acts on parasympathetic nervous system, that is parasympathomimetics and parasympatholytics or parasympathetic blockers. Now, parasympathomimetics, as the name itself indicates, that these drugs will copies the effects of acetylcholine stimulation or acetylcholine release on any particular organ containing or system containing acetylcholine receptors. So these drugs can be defined as the drugs that combines with acetylcholine receptors and produces similar effects in the end organ or effector organ as that produced by acetylcholine in the normal release. That means whenever acetylcholine is released in our body, whatever effects it shows on different parts or organs or systems containing acetylcholine receptors, if same effects are produced or shown by any foreign substance or drug, then such drug will be known as parasympathomimetics, because it is copying the exact effects of natural acetylcholine in our body, or those drugs or chemicals which stimulates parasympathetic nervous system or mimic the responses of acetylcholine are called as parasympathomimetics. Now, classification. All parasympathomimetics, you can divide them into two parts, or there are two broad classes you can say. First one is directly acting cholinomimetics, or they are also referred as true cholinomimetics, which includes acetylcholine, methocholine, carbachol, muscarine, nicotine, pilocarpine. And second category of drugs are indirectly acting cholinomimetics or anticholinesterase or acetylcholinesterase inhibitors. Now, the name itself suggests that these drugs will inhibit an enzyme called acetylcholinesterase. The function of this enzyme is it catabolizes, or you can say metabolizes, or breaks down acetylcholine molecule into two parts, that is acetic acid and choline molecule. Now the structure of acetylcholine is written on the top of this page. You can see that acetylcholine chemically is a ester, that is RCOOR dash, where CH3 is your R, COO, and remaining molecule is your R dash. So this ester will be cleaved by the enzyme called acetylcholinesterase, and these drugs will block this enzyme, thereby acetylcholine will not be metabolized and it will be available for its action. Now, these agents are of two types. One, you call them as reversible anticholinesterases. That means once the purpose is over, the action of these drugs will be over, and acetylcholinesterase enzyme will be free to metabolize acetylcholine molecule. On the contrary, there are second types of agents which are called as irreversible anticholinesterases or organophosphorus compounds. Now, these are not drugs actually. These are poisonous substances which are present normally in insecticides and pesticides. So, whenever one consumes these substances either intentionally or accidentally, what happens? These organophosphorus compounds, they binds with acetylcholinesterases, thereby acetylcholine cannot be metabolized, and these enzymes are also will not be freed because of the permanent binding with these substances, and the net result will be acetylcholine will continuously show its action at all the places, and because of this sudden action of acetylcholine on all places or on all receptors and the effector organs, a person can die, or he can be under emergency situation, or there will be a threat to his life because of consumption of such substances. So actually these are not drugs, these are poisons or poisonous substances which are present in insecticides and pesticides. They are called as irreversible anticholinesterases, or they can be classified under irreversible anticholinesterases. So this second category have no therapeutic value or no therapeutic use, and they can be used, actually they can also be used as nerve gases in case of wars, as a chemical weapon, you can say. Now, examples of reversible anticholinesterases are neostigmine and physostigmine, pyridostigmine, etc. Now, after classification, the first chemical compound which is there in this chapter is physostigmine, which is a natural compound, or you can say natural alkaloid obtained from dried ripe seeds of Physostigma venenosum. So this is a natural alkaloid which can be used as parasympathomimetic agent. Now, the structure of this physostigmine is displayed on your screen. This structure consists of three fused nucleus. One is a six-membered aromatic ring, and two rings are heterocyclic nucleus, five-membered heterocyclic nucleus. So it is a tricyclic fused heterocyclic nucleus. Actually, it is a combination of two rings. One is pyrrole and another is indole. When you separate them, it is a combination of pyrrole and indole. So that's why when you focus on the chemical name of this molecule, at the end you will find pyrrolo 2,3-B indole. So one fused ring is indole molecule and another fused ring is a pyrrole nucleus. Now these two rings, actually it is three rings, out of which one ring is a single ring and another ring is a combination of two rings, that is one aromatic ring and one pyrrole ring, which is called as indole. Collectively it is called as indole. So it is a fusion of pyrrole and indole, and this pyrrole and indole, they are connected with each other or joined with each other through 2,3 side of pyrrole and B side of indole. So collectively this molecule is called as pyrrolo 2,3-B indole. That is a fused heterocyclic nucleus which you can treat as a base while naming this molecule. Again, you can see that if you focus on the whole structure, you will find a functional group is also directly attached to this is fused heterocyclic nucleus, and this molecule can be considered as a ester, RCOOR dash, where R is CH3NH, COO, then R dash is your fused tricyclic nucleus. So you can collectively take a fused heterocyclic nucleus along with functional group as a base in the form of ester.